Let's talk about reactions of ethers. The most important reaction of ethers that you have to know is the acidic cleavage of ethers to produce an alkyl halide. And this acidic cleavage works best with hydrobromic acid or hydroiodic acid. Now, when we take an ether and we treat it with HBr or HI, it says here that if the R group on the ether is tertiary, then the cleavage is going to occur via an SN1 mechanism. If it's primary or secondary, it's going to occur via an SN2 mechanism. Now, if the R group is vinyl or aryl, we're not going to get any substitution whatsoever. So if you take a look at this example here, now let's say the R is an alkyl group, and then of course here we have an aryl group, right? This is an aromatic ring or an aryl. Well, remember, it says that if you have an aryl group, you're not going to get any substitution occurring. And so when we take our ether and we treat it with HBr or HI and we heat it, okay, we're going to end up breaking only this bond, the one between the oxygen and the alkyl group, and then we're going to end up with phenol as our product and the alkyl halide. Probably the best way to understand what happens in this reaction is to take a look at an example. Let's do that right now. It says here, predict the products for each of the following reactions. So if we take this symmetrical ether here, the one on the top left, and we treat it with excess hydrobromic acid and we heat it, what's going to happen? The easiest way to solve these problems is just to draw a line that shows the breakage of the bond between the oxygen and the carbon. So those are the two bonds that we're going to break. What we're going to get is first we're going to draw the carbon skeleton that I'm boxing here in red. So we're going to end up with this carbon skeleton. Those are the 4 carbons of the skeleton. And instead of a bond to oxygen, we're going to have a bond to a bromine. Now, the same thing is going to occur on this side of the molecule. And so we're also going to get another molecule of that same alkyl halide. And then where's the oxygen going to go? What's going to happen to that oxygen? Well, that's going to come out in water, in H2O. And so what we get is if we take this symmetrical ether and treat it with excess HBr and heat, we get 2 moles or 2 molecules of the alkyl halide, and we get some water. Let's take a look at the next example. We're starting with THF and we're treating with excess hydroiodic acid and heat. Well, we're going to do the same exercise. We're going to break these 2 bonds here. So how many carbons do we have left over? We've got CH2, 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 CH2. So we've got 4 carbons. Let's draw those out. 1, 2, 3, 4. Now what's going to be attached to each of those carbons is going to be an iodine. So let's put that in. I have an iodine on this end, and I'm going to have an iodine on this end. Where's the oxygen going to go? It's going to come out in water like that. And so I end up with 1,4-diiodobutane and water in this case. Let's try the last example. This one we have ethoxybenzene, and we're treating with excess HBr and heat. Remember, we can't break this bond because that is an aryl ether. And if you remember, we can't break the bond of an aryl ether when we treat it with HBr or HI. However, we can break this bond right here because it's to an alkyl group, right? It's to an ethyl group. And so what we're going to end up with is products. In this case, is we'll end up with our aromatic ring, which will still have the oxygen attached, but now it will have a hydrogen, and that is called phenol. And we're also going to end up with our ethyl group, and it's going to have a bromine attached like that. And so to summarize, if you take an ether, and I'm going to start with an unsymmetrical ether here, and if you treat that with excess hydrobromic acid or hydroiodic acid, and you heat that up, what you're going to do is you're going to end up with the R prime group attached to the halogen. You're going to end up with the R double prime group attached to a halogen, and you're going to end up with water. And so that is the reaction that we saw in that last example. So this is the acidic cleavage of an ether. Another reaction of ethers is called autooxidation. And basically what happens is if you take an ether like diethyl ether, and if you let it be exposed to oxygen from the air, over time it's going to form what's called a hydroperoxide that's shown here on this slide. We see the hydroperoxide. And so laboratory samples of ether have to be frequently tested for the presence of hydroperoxides before they get used, because hydroperoxides are in fact explosive, and we try to avoid explosions in the organic chemistry lab. I'm not going to quiz you or ask you any exam questions about autooxidation, but you should know that it occurs via a free radical mechanism.